Good morning, students. Welcome to a fresh session. In the previous video, we have stopped in question number 6. So we're going to start with question number 7 from this class. Now let us read the question once. In a magic square, each row, column, and diagonal have the same sum. Check which of the following is a magic square. Okay, now in this question, they have given us that there are two squares. As we can see in the question, there's part 1 and part 2, which includes two squares. Each square has rows, columns, and diagonals. As you can see, there are 3 rows in the question, and there are 3 columns, and there are 2 diagonals. So first of all, we need to understand what row, column, and diagonal are. So the cells taken in this direction or this direction are called the rows. The cells which are taken in this direction or this direction are called the columns, and the cells which are taken in this direction or this direction are called the diagonals. Okay, now let's look at the next part of the question. So they have told us that all the rows, columns, and diagonals should have the same sum. What does this mean? It means that there is a condition for the square to become magic square. Now, we can call one of the squares a magic square only if the sum of rows is equal to the sum of columns is equal to the sum of diagonals. Okay, so we're going to check this condition for both the squares and see which of the square is a magic square. Let's check. The first question. As you can see, there are 1, 2, 3 rows, 1, 2, 3 columns, and 1, 2 diagonals, right? So now we have to find the sum of each row, okay, and then the sum of each column, and then the sum of each diagonal, and see whether all these sums are equal or not. If it is equal, then we can say that the square is a magic square. So let's start with row 1. In row 1, as you can see, there are 3 elements, 3 cells, 5, -1 and -4. We need to find the sum of row 1. So we take 5 plus -1 plus -4 as we are finding out the sum. In the next step, we simplify it using the rules that we have studied in the class. Plus minus, minus, plus minus becomes minus again. The numbers will remain the same. Now we have 3 numbers. So in the next step, we will be taking 2 numbers, solving it and going it in the direction. As we can see, 5 minus 1 becomes 4 and 4 repeats itself. Now we have only 2 numbers, so we can solve it. 4 minus 4 becomes 0. Now we have the sum of row 1. Likewise, we are going to find the sum of row 2 and row 3 as well. Row 2 contains 3 elements again, -5, -2 and 7. Row 2 sum is equal to -5 plus -2 plus 7. Take all the 3 elements and add them, right? Now, as you can see, -5 will remain the same. Here we have to use the rule, plus minus will become minus and plus will again remain the same. Let's see. -5, -2 plus 5. Why? Plus minus becomes minus according to the rule. Now we have to take the first 2 numbers. Minus minus becomes plus. So we get 5 plus 2, 7, and minus because the greater number sign is minus. So -7 and the +7 repeats itself, +7. Now we have 2 numbers. We can solve them using the rule minus plus minus. So 7 minus 7 will give us 0. So we have found the sum of row 2. Now we are going to find the sum of row 3. Again, 3 elements, we add them using the same procedure we used in the previous row. As you can see, 0 plus 3 plus minus 3 becomes 3 plus minus 3. 3 minus 3 becomes 0. Therefore, we can say that sum of row 1 equal to sum of row 2 equal to sum of row 3, because we got 0 for every answer. Now we're going to take columns since all our rows are over. So the column 1, the same procedure that we continued for rows, we're going to continue for columns as well. The first column contains 3 elements again, 3 cells. First cell contains 5, second cell contains minus 5, and the third cell contains 0. So we're going to add them, 5 plus minus 5 plus 0. So sum of column 1 is 5 plus minus 5 plus 0. Now let's see, plus minus will become minus according to the rule. Integer addition we have done in the all the previous classes. So make sure that you know that before you come into this video. Otherwise, please revise the previous classes. Let's see what will be the next step. 5 minus 5 plus 0. 5 minus 5 becomes 0. 0 plus 0 becomes 0 again. So we have the sum of column 1. Now we go on to column 2. Column 2, the same procedure repeats. We get minus 1, minus 2, plus 3. Same procedure, integer addition. Minus 1 and minus 2 becomes minus 3, plus 3 repeats itself, plus minus minus. So 3 minus 3 will give us 0. So now column 2's sum is also found. Now we can go on for last column, which is column 3. Column 3 contains 3 elements again, minus 4, 7 and minus 3. We add them. Using integer addition, we get 3 minus 3. 3 minus 3 is 0 clearly. So now again we get that sum of column 1 equal to sum of column 2 equal to sum of column 3, which as you can see in the previous steps, 0. So after completing these two steps, we have gotten that all the sum of the rows are equal and all the sum of the columns are also equal. Now we need to check for the diagonals. Only if, remember the condition, only if the sum of rows equal to the sum of columns equal to the sum of diagonals, only then the square will be called a magic square. So we have checked for rows and columns already and we have found that they are equal. Now we are remaining with the two diagonals. We have to check if the sums are both 0, both equal, then we are going to get that it is a magic square. Otherwise, it is not going to be a magic square. So let's continue. Now the first diagonal, diagonal 1, you can take any of the diagonal as diagonal 1, either this diagonal or this diagonal. Here the diagonal has 5 elements, 3 elements, 5, minus 2 and minus 3. Sum of diagonal 1 is 5 plus minus 2 plus minus 3. The elements, we have added them because we have to find the sum. Now using integer addition we proceed. 5 plus minus becomes minus. Again plus minus becomes minus 3. Now we take the first two numbers. 5 minus 2 becomes 3 in the next step, minus 3. So 3 minus 3. 3 minus 3 is 0. Now we got that sum of diagonal 1 is also 0. Now we have to find the last diagonal sum, which is diagonal 2. Now the second diagonal contains 3 elements again, minus 4, minus 2 and 0. We add them using our traditional method that we have learned up until now, which is integer addition. Using the rules we get minus 4, minus 2 plus 0. Clearly minus 4 minus 2 is minus minus plus. So 4 plus 2, 6. And since the greater number sign is minus, the answer will be minus 6 plus 0, which is clearly minus 6. So now we have got that sum of diagonal 1 is 0 and sum of diagonal 2 is minus 6, which are not equal. So therefore we can say that sum of diagonals is not equal to sum of rows is equal to sum of columns. Rows and columns are equal, but we have got the diagonals are not equal. Why? Because one is 0 and one is -6. So that means this is not a magic square, right? So, which means we can conclude that this is not a magic square. Now, let's proceed on to the next question, which is question number 8, right? Now, before that, question number 7, one more question is there, one more square. So, you'll follow the same steps and I want you to do it as a classwork in your copy. Please make sure that you have followed the same steps, understood how I did the first question, and repeat the same steps for the second question so that it will be a revision for you. Alright? Now, let's proceed on to question number 8. Question number 8 is verify a minus b is equal to a plus b for the following values of a and b. So in question number 8, when you look at question number 8, you have been given 4 subdivisions. Each subdivision contains one value for a and one value for b, and as you can see, they have asked us to verify. Now the main aim of the question is to verify. What does the word verify mean? Verify means to check. Okay, so what are we going to check? We are going to check that a minus b is equal to a plus b, right? A minus b is equal to a plus b. That is what we are going to check here, right? Now when you look at this equation, why do we call it an equation? Because there's an equal sign, right? Two things are equal, right? So it's an equation. Now let's look at this equation carefully. We can see that there is a left hand side. The side of the equal to, which lies on your left hand, is called the left hand side of the equation, right? Likewise, the side on the right hand side of the equation of the equal to sign, right? If you look at the equal to sign, the side which lies on the right side of the equal to sign is called the right hand side, and the side which lies on the left side of the equal to sign is called the left hand side, right? Clearly. Now, in order to check this equation, what we need to do is we need to check if the left hand side is equal to the right hand side or not. This equation is correct only when we can say the left hand side is equal to the right hand side. Okay, that is the only time when we can say that this equation is correct. Okay, so we are going to check whether this equation is correct or not. That is what we are going to verify. And in order to verify this equation, what do we have to do? We need to check whether this side is equal to this side or not. That is, the left hand side equal to right hand side or not. Okay. Now let's look at the first question. The first question, we have A 21 and we have B 18, right? So first let's take the left hand side. Now as you can see, the left hand side is A minus B. Now as you can see, A has a value which is given in the question, so we will substitute that value. B has a value given in the question which is 18. We will substitute that value. Substitute means to put in place of, right? So in place of B, I'll write 18 because B is equal to 18 given in the question. And in place of A, I'll write 21. Why? Because A is equal to 21 given in the question, right? So let's see. Now I have substituted A is 21 minus from the equation minus 18. Why? Because minus is again from the equation, 18 is B, right? Now let's solve this using integer addition that we have studied. Minus minus is plus, so it becomes 21 plus 18, and as you can see, 21 plus 18 is 39, right? So likewise, we are going to take the right hand side as well. The right hand side of the equation is A plus B. As you can see, A minus B, and the right hand side will be A plus B. right? So in a plus b, again we're going to substitute the values. A is 21 and b is 18 from the question. So let's substitute. 21 plus 18, clearly it is 39, right? So now you can see that left hand side is also 39 and right hand side is also 39, and that is what we needed to check, right? So we have checked and we have found that the left hand side is equal to the right hand side. So what can we say now? Since the left hand side is equal to the right hand side, we can say that it is verified. That means we have checked. Okay, and what did we check? We checked if the left hand side is equal to the right hand side or not, and we have checked and got that the left hand side is equal to the right hand side in this question. So likewise, let's look at the second question. Question 2. Again, the left hand side of the equation is a minus minus b. This is given in the question. The equation will always be given in the question. So the left hand side of the equation is minus a minus minus b. Now a is again given in the question, b is also given in the question. We just need to substitute or put in place of a and b these numbers that are given in the question, right? So in place of a, I will write 118, and in place of b, I will write 125. Using integer addition again, minus minus becomes plus. So 118 plus 125, as you can see, minus minus will become plus. 118 plus 125, we get 243. So likewise, we are going to check for the right hand side. Right hand side is a plus b. A is 118, b is 125. We substituted. As we substituted, we get 118 plus 125, which is 243. So now again you can see right hand side and left hand side are equal. Left hand side and right hand side are equal. So when it's equal, what can we say? We can say that left hand side is equal to right hand side, and that is what we had to check, and that is what we had to verify. So we write hence verified. So we have verified that the right hand side is equal to the left hand side, right? Now let us go on into the ninth question. Before beginning the ninth question, I want to bring to your notice that in question number 8 there are two more parts, part 3 and part 4. Only the numbers have been changed. The rest of the question is the same. So kindly try it by yourself in your class workbook. That is also your class work, right? Question number 7, I want to repeat. Question number 7, 2 is a class work. Question number 8, 3 and 4 is also a classwork. So please make sure that your notes are complete in your book, and when I take to check, I want these marks, these answers in your book, according to which I'll be giving you your internal marks. Okay, so make sure that your work is complete. Now let us go on into question number 9. As you can see, question number 9, let's read. Use the sign this, this or this in the box to make the statements true. Now when you look at the question, you can see that there are two sides to the question and there are boxes in the middle of each question, and we need to substitute these signs inside the boxes in order to make the statements true. Okay, so we have to make the statements correct. Now let's look at the signs and understand what these signs are. The sign is called the greater than sign. You all know it from the lower classes. The sign is called the lesser than sign, and the sign is called the equal sign. Now these signs are always used to compare two numbers in mathematics, right? So keeping these signs in mind, let's look at the first question. The first question is -8 plus -4. We have to put the sign in the box, and the rest of the part is -8 minus -4. So as you can see, there are two parts, this part and this part, and we need to substitute the appropriate value. Before substituting the appropriate value, let's look at the question. We need to solve this question because it is unsolved, right? So we need to solve this also, we need to solve this also, and come up with singular numbers in order to be able to compare, right? So let's look at the first part, -8 plus -4. As you can see, -8 will remain the same, plus minus will become minus, and 4 will remain the same. Minus minus will become plus, so 8 plus 4 will be 12, and greater number sign, -12, right? So I will not repeat the same procedure again because we have done integer addition and subtraction several times. So this is just to show you what is going on in this question. Make sure that you understand the calculation. It is the same like we have done in the previous questions, right? So minus 8 minus minus 4, again minus minus becomes plus, minus 8 remains the same, minus plus becomes minus. So 8 minus 4 is 4 and greater number sign minus, right? So we know that minus 4 is greater than minus 12. As you can see, we have got minus 12 in the first part and minus 4 in the second part. So we know that minus 4 is greater than minus 12, as I've taught you in the first class how to compare negative integers, right? So we can see that minus 8 plus minus 4 and minus 8 minus minus 4. So we have two parts of the question, and for the first part we got minus 12 and for the second part we got minus 4. So let's substitute the sign in the box. The sign is less than sign, which means the first part of the question is less than the second part of the question, which is minus 12 is less than minus 4. So the appropriate sign is less than sign, right? Now let's look at the second part of the question. Second part of the question, again the same type of question. We have one part and we have another part, and we need to solve these parts and come up with a singular number so that we can compare. And this is the box where we need to put the comparison symbol, which is greater than or less than or equal to. Okay, so let us solve this again using integer solving procedures that I have taught you in the previous classes. Minus 3 plus 7 becomes 4, minus 19 remains the same. 4 minus 19 is minus 15 because 19 is the greater number and greater number sign is minus, so minus 15. And you can see here minus 15. 15 minus 8 plus minus 9, second part of the question. We solve it to get minus 2. As you can see, we have got minus 15 on this side and minus 2 on this side. And by comparing the two integers that we have got, we know that minus 2 is greater than minus 15, right? All these things have been taught in the first class. Please revise those classes before coming and watching these classes, all right? So now we know that minus 2 is greater than minus 15, which means that we can conclude that the given two parts, we can see the first part is minus 3 plus 7 minus 19 and 15 minus 8 plus minus 9. When we solved, we have got two integers, minus 15 and minus 2. Respectively, we can put the sign less than. Why? Again, the same symbol less than, because the first part is minus 15, this is minus 15, and this is minus 2 when solved, and minus 15 is less than minus 2. So we can put the less than symbol, right? So likewise, I'm going to solve the question E. E part of this question I'm going to solve, because C and D is the same type, and C and D again is going to be a homework. E is also the same type, but since little larger numbers are involved, I am solving it here. C and D is also homework for you to do and come when the offline classes begin. Alright. So now let's look again, two parts, first part and second part. We need to solve the first part, come up with a single number. Solve the second part, come up with a single number. As you can see, normal integer addition and subtraction is involved. Only difference is numbers are a little large, but we'll follow the same procedure, right? So minus plus, we have minus. So 231 minus 79. Or you can also do one more thing. Look here, this is a negative integer, so put it as it is. Then you take the positive integers and you add them, and then you can solve it in order to become easy. You can either take the first two numbers and solve it, or you can take the last two numbers and solve it. It does not make any difference. You will get the same answer. So by solving it, we get the final answer minus 101, and the second part, the final answer minus 159. Again, minus plus minus, minus plus minus. The same rule applies, and we get minus 159, right? In the previous questions, I've always taken the first two numbers, solved it, and when I come up with an answer, I take that answer and solve it with the third number, right? But here, in order to make it a little more easier, since according to the numbers we can change, we can either take the first two or take the last two. The order does not matter. the same answer is going to be obtained. So I take the last two numbers and add them, which I get 130. 231, I put it as it is. Then now I have two numbers and I can solve that. Plus minus is minus and the greater number sign is minus. So the answer will also have minus. And 231 minus 130 is 101. So likewise, the same procedure carries out here and I got 159. Now we know that looking at both the integers, minus 101 is obviously greater than minus 159 according to the integer comparison rules, right? So getting this, we can write minus 231 plus 79 plus 59 is greater than minus 399 plus 159 plus 81. Why? Because as you can see, this part when I solved I got 101 and this part when I solved I got 159, and 101 minus 101 is greater than minus 159. Okay, so now proceeding on to the next question, let's see. So now let's do question number 10. Let's read the question. A water tank has steps inside it. A monkey is sitting on the topmost step, that is on the first step, and the water level is at the 9th step. Now let's see. This is a water tank. It has steps inside it, as you can see, and a monkey is sitting on the topmost step, that is on the first step, and the water level is at the 9th step. So that means the 9th step is the last step. So we can see the steps 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have 9 steps in total. A monkey sitting on the top of the step, and at the 9th step the water touches the step, which means the water level is at 9th step. Total of 9 steps, right? Now keeping this in mind, let's see what the question asks us. The question has 3 parts. The first part is, let's read the first part. He jumps 3 steps down and then jumps 2 steps up. In how many jumps will he reach the water level? Okay, so let's look at this question carefully. Let's see. This monkey is sitting on the topmost step. Now, he has to jump all these steps, okay, in a particular pattern and reach this step in order to drink water, right? So now, in what manner or in what fashion does he jump? He first jumps 3 steps down and then 2 steps up. Let's look at his motion. 1, 2, 3. He jumped 3 steps, right? 1, 2, 3. After 3 steps, he is on the 4th step. As you can see, he's on the 4th step, right? Now what does he do? He goes 2 steps up. After jumping 3 steps down, he goes 2 steps up. Let's see. He turns 1, 2. So he jumped twice and reached the 2nd step. So first we saw that he was here, then he went here to the 4th step, and then he goes to the 2nd step, right? So now again he has to continue the same procedure until he reaches this step where he can drink the water from, right? So let's see what he does. He turns and he starts jumping. Now before jumping, let's see, after the first jump he reached this position. So let's name it J1. After that he turned back and jumped again. So let's name this step J2 because this is the step which he's at present, right? So he jumped once and reached J1, then he jumped back and reached J2. So that means he jumped 2 times now, right? So let's carry on this procedure to find out how many times he jumped, okay? So he turns and carries out the same procedure. He jumps 3 steps down and 2 steps up. Let's see. 1, 2, 3. So now he's at the 5th step. As you can see, he is at the 5th step. Now he has to go 2 steps up. He turns 1, 2. So now he goes 2 steps up and he's at the 3rd step, right? Now let's see, this procedure continues again. So in the previous slide, we have seen that his position was this after he jumped 3 times, third time, and then this when he jumped the fourth time. And now he's at this step, right? So we can name this step as J3 and this is J4. Now if you remember, this one was J1 and this one was J2. Now we have J3 and then we have J4. Now let's see how he arrives at J5. He was at the third step, J3, and now he has to jump 3 steps down again. Let's see. 1, 2, 3. So jumping 3 steps now, he is at the 6th step. Now he has to go 2 steps up. Let's see. 1, he turns. 1, 2. So he jumped 2 times and he reached this step, which is the 4th step, right? So now let's see, this was the step he reached next. So we saw that this was J1, then this was J2, then this was J3, and this was J4. Likewise, this is going to be J5 and this is going to be J6. So let's see, his last position right now is going to be J6. And his previous position is going to be J5. Let's see. J5 and J6, right? Now that means he has jumped 6 times and he has reached here, right? So let's proceed on to see where does he go next. Now he's at this step after jumping. Now let's see how he jumps again. 1, 2, 3. So he'll come at this step, right? So let's see the procedure. 1, 2, 3. So after 3 more jumps, he reaches at this step. Now what he has to do again? He has to go up 2 steps back, right? So he turns and he goes 1, 2. So 2 steps up again and he reaches the 5th step. So now let's see again, he has to continue this procedure again and again unless he reaches the 9th step. So let's see what he does again. He turns. And before jumping, let's see his position. In the 7th jump, he reached this step. And in the 8th jump, he reached this step, which is the 5th step, right? So let's see. He's at the 5th step right now after jump 8. Now let's see the 9th jump. 1, 2, 3. So after 3 jumps, he's at the 8th step, right? And he has to go 2 steps up. So let's see. Turns. 1, 2. So he jumped twice and reached the 6th step now, right? Now, what does he have to do? Keep repeating the same procedure. Before that, let's see his last position. It was J9. After he jumped 3 steps, he reached J9. And then he reached J10, which was his last known position. Now from J10, he's going to jump again. Let's see. That means he has completed 10 jumps and now it's going to be his 11th jump. Let's see what he does in his 11th jump. 1, 2. Please carefully look at these steps once more. We're going to repeat it. Before repeating and looking at the steps, let's see his last jump was jump 11, which means from the diagram itself, we can say that he jumped 11 times from the top in order to reach the water level. How did he jump? Let's see. 1, 2, 3, and then he jumps 2 steps up. 1, 2. So as you can see, it is mentioned in yellow so that you'll understand, right? First he came to yellow and then went back to yellow, right? And from yellow, where did he go? He came to the second green and then went to the first green, right? And then from the second green to the third pink and then to the second pink, right? Now again to the second green and then to the third green, right? So likewise, he repeats this procedure. So let's see, 1, 2, 3, goes back, 1, 2. He's here right now, right? Now again, 1, 2, 3, he goes back again to 1, 2, right? So now again, 1, 2, 3, he goes back to 1, 2. He's here right now. Now 1, 2, 3, he goes back to 1, 2. So he's here right now. Next 1, 2, 3, he goes back twice, 1, 2. So he's here right now, which is the 10th jump. Now let's see, 1, 2, 3, which is 11th jump. Okay, so every time he jumps forward, that is counted as J1, and every time he jumps backward, it's counted as J2. So continuously forward and backward jumps are counted J1, J2, J3, J4, J5, J6, J7, J8, J9, J10, and then J11, right? So that is what we did. Now let's understand this question in a systematic manner. So when he was at the first step, he jumped 3 times. So he reaches the 4th step, which is 1 plus 3, 4th step, right? Now from the 4th step, he has to go back up 2 steps, right? Now before understanding this, let's look at this important point. Going down is positive and going up is negative because we are minusing the steps of going up, right? Going up means reversing or subtracting, right? Subtracting his position. So going up will be taken as negative and going down will be taken as positive because we're increasing the steps, right? So increasing the steps means going down and decreasing the steps means going up, going farther away from the water, right? So now let's see. 1 plus 3 steps give us 4 steps. Now he's at the 4th step, but he has to jump 2 steps back up. So 4 minus 2, second step. He reaches the 2nd step. Now again this 2nd step will continue here. He's at the 2nd step and he has to jump 3 times. So he reaches the 5th step. Now this 5th one will continue down here again. 5th step and 2 steps down and 3 steps. 5 minus 2 is 3, right? So you can see a pattern here. 1 plus 3 is 4. This 4 repeats here, minus 2, 2nd step. 2nd step repeats here, plus 3, 5th step. 2 plus 3, 5th step. 5 repeats here, again 2 steps, 3rd step. So the same procedure keeps repeating. Whatever we have seen in the question to understand, it is written here, right? So please make sure you understand this. He was at the first step first, then he has to jump 3 steps from the question, right? He first jumped 3 steps forward and then jumps 2 steps backward. So this is why we're adding 3 steps and subtracting 2 steps in every step alternatively. 3 step, 2 step, 3 step, 2 step, 3 step, 2 step. So you can see the continuing pattern, right? And you can see that he was at the first, so we started from first and at last we reached the 9th step. That was our purpose. Our purpose was to take the monkey from the first step and take him to the 9th step, right? So why did I add 3 steps here? Because it's given in the question that he goes 3 steps ahead first. And then why did I subtract minus from here? Because from the last position of his, which is he was at 4th step, and we have to minus 2 steps because he goes back up 2 steps, right? So that's why we minus 2 steps. So now keeping all these procedure in mind, we can see that he jumped how many times? He jumped 1, 2, 3, etc. 11 times. Total of 11 jumps in order to reach the 9th step, right? So as you can see, 11 jumps. So what can we say? Total number of jumps is 11, right? Let's see the second part. After drinking water, he wants to go back up. For this, he jumps 4 steps up and then jumps 2 steps down in every move. In how many jumps will he reach back the top step? Now, the main things that we need to understand in this question are that after drinking water means he is at the 9th step, obviously. After drinking water, he wants to go back up, which means he's at the 9th step and he wants to go back up. So in order to go back up, he does some things, right? So let's see what are those. First, he goes 4 steps up and 2 steps down. 4 steps up and 2 steps down, right? Now, looking at that, we can see that going up means negative because he's decreasing, right? And coming down means positive. So that is how we will take it, right? Just like we have done in the first part of the video, right? So now we're going to continue with this question. Let's read the question once more. After drinking water, he wants to go back up to the first step again. For that, what does he do? He jumps 4 steps up. So he's going to go 1, 2, 3 and 4 steps upwards and then jump 2 steps down, 1, 2. Going up is taken as negative and going down is taken as positive, just like in the previous question itself. And keeping these things in mind, let's see in how many jumps will he reach the top step. So the same procedure that was carried out in the first question, let's see, he's at the 9th step now. He goes 4 steps up, and up is negative, so we take minus 4, so 9 minus 4 we get 5. That means he's at the 5th step. So he's at the 9th step, then he jumps 4 steps up and he reaches the 5th step, right? So same manner, 5th step, he's at the 5th step, so 5 continues. 5th step, then he goes 2 steps down, right? So 2 steps down, and down is positive, so we take plus sign. So he's at the 5th step and he jumps 2 steps down. So 5 plus 2 we get 7th step, which means now he's at the 7th step, right? Again, he's at the 7th step. He wants to go 4 steps up. Up is negative, so minus 4. 7 minus 4 we get 3, which means he's at the 3rd step now. But according to the rule of the question, he's at the 3rd step now and he has to go back 2 steps down, which means 2 steps down, so plus 2, which means he's at the 5th step now. And from the 5th step, he has to go 4 steps up according to the rule, and since it is up, it is negative. So 5th step to 4 steps up, he reaches the 1st step. Now we can stop our procedure here. Why? Because we wanted him to reach the 1st step, right? So we stop the procedure here, okay? So that means he was at the 9th step and now he's at the 1st step after carrying out all these procedures, right? So we can see that he jumped 1, 2, 3, 4 and 5 times. First he jumped 4 steps up, then 2 steps down, then 4 steps up, then 2 steps down, then 4 steps up, and he didn't have to jump 2 steps down because he had already reached the 1st step, right? First he was at the 9th step, then he reached the 5th step, then he reached the 5th step, and then he reached the 7th step, then the 7th and the 3rd, and the 3rd and the 5th, and 5th and the 1st step. So that is how steps are. These show the steps and these show his jumps, right? So he jumped how many times? 1, 2, 3, 4 and 5 times he jumped in order to reach the 1st step, right? So as we can see, he was on the 9th step and he had to jump 5 times in order to reach the 1st step. So as we can see, the total number of jumps, that was 5. So he jumped 5 times in order to reach the 1st step from the 9th step. So now, as we can see, we have easily solved all these questions, keeping in mind the knowledge that we have gained from the first video and from the second video classes, right? So main thing that you need to study in order to solve these questions is integer addition and subtraction, right? So by using that, we have solved all these questions. Now I want you to try the third part of this question. It is extremely simple. Please read the question, try to understand, watch the video from the beginning, understand the question and try to do it by yourself. And next class I will be explaining the third part, but I want you to try it by yourself, okay? And before coming for the next class, we'll be starting a fresh topic, which is properties of integers, right? And before starting properties of integers, you need to know what are integers and what are the different features that we have studied, like addition and subtraction, multiplication, etc. of integers, right? So whatever we have studied, which is addition and subtraction of integers, please make sure that you know all those so that we can proceed with the next part of the chapter. So till then, see you. And please make sure that you are well revised and well versed with all the things that I've taught you in the previous classes. Thank you.